Hello class, it's Mr. Ng, and here is chapter 3 of Joncali, number 17. Number 17 is a pretty quick and easy one. It looks almost exactly like the strategy that you might have used to solve the math when we dropped those little ball bearings and they kind of fell and also went across, right? A very classic two-dimensional problem. So let's look at the problem. A tiger leaps horizontally from a 6.5 meter rock with a speed of 3.5 meters per second. How far from the base of the rock will she land? Well, it doesn't look like we have a lot of information, but there is a lot of information here. So we have a rock, and the height of this rock is 6.5 meters, right? That's how tall this rock is. And then this little tiger is going to jump across at 3.5 meters per second. So there's actually two systems here that we need to worry about. There's the vertical system, so we're going to call that the Y, and then there's also the X system. So let's deal with the vertical system first because we know more here, right? Namely, we know the initial. V final we won't know, right? Let's not do a thing there. Acceleration, time, and x. We know that the v initial is 0, right? Because when we just think about it vertically, this cat is moving horizontally, so there's no up and down going on just yet. We know that acceleration is 9.8. I know some of you might do negative 9.8, but the x is going to be the x is going to be negative also, so I'm just going to make them both positive. Does that make sense? Right? And the x is going to be 6.5 meters. And I think the best strategy here is to find time, right? This is kind of the strategy that we did when we did our lab. So we want to find time with these variables. If I went up here, I think I'm going to use this equation. So this is to solve for y. X is equal to x naught plus v naught times time plus 1/2 at squared. This is nothing. This is nothing because this is 0 and 0. So x is equal to 1/2 at squared, or x is equal to 1/2 g, as in gravity, t squared. And then I just need to rearrange it so that it becomes t. So I'm going to multiply it by 2. X divided by g is equal to t squared, square root, t is equal to the square root of 2x divided by g. Let's fill in. That means that t is equal to 2 times 6.5, square root of that, divided by gravity, which is 9.8, the whole thing, please. Right, this is an 8. And the time that I got was 1.15 seconds. Don't need to worry about sig figs just yet. Let's worry about sig figs when we get to the very end. That's part of the answer. Now we get to figure out the x stuff. So v, a, t, x. And now we know that this is 1.15 seconds. V initial we know is 3.5 meters per second. In this setup, the V final is also 3.5 meters per second, because the acceleration is 0, right? Yeah, there's acceleration going down, but there's no acceleration going sideways, right? It's just flying through the air. We're ignoring air resistance. So x is what we want to find out. Well, I think the easiest one, none of these. Let's just use the definition of velocity, right? We know that velocity is equal to displacement over time, right? The velocity is 3.5. That means displacement is equal to velocity times time. Displacement now is going to be 3.5 meters per second times 1.15 seconds. Seconds will cancel. So our displacement is going to be 4.025 meters. Great. If you notice, it only gives us 2 sig figs, so it can't have these digits here. So x is really equal to just 4.0 meters. And that is our answer. Thanks a lot for watching. I appreciate all the work that you guys do. Keep working hard.